Let's jump right in. Welcome to The Explainer. Today, we're tackling something absolutely crucial, demystifying the tech that's literally driving the modern AI revolution. We hear about AI all day, every day, but today, we're going to break down exactly how the engine actually works. So, let's get into it. So, what exactly is an LLM? It's kind of the fundamental question of our time, right? You hear the acronym LLM everywhere, and you know it's the brains behind tools like ChatGPT. But what is a large language model, really? Surprisingly, few people actually know what's going on under the hood. Okay, here's our roadmap for today. We'll be demystifying LLMs, looking at how do LLMs work, building the AI brain, taking a brief history of AI, checking out the key players in the industry, and finally looking at the future of AI. All right, part one, demystifying large language models. At its very core, a large language model is an AI system trained on an absolutely massive mountain of textural data. We're talking terabytes and petabytes of information. By absorbing all of this text, the system infers patterns to generate human-like writing, code, or even media. It's basically absorbing the complex patterns of human communication just to be able to speak right back to us. Moving on to part two, how do LLMs work? Now, here's the absolute crucial point you need to understand. LLMs do not actually understand language the way you and I do. They aren't sentient thinkers pondering the meaning of life. Instead, they are essentially highly advanced prediction engines. When you hand an LLM a prompt, it's really just predicting the most probable sequence of words to follow, all based on pattern recognition. Let's look at a fun example. Say we give the AI a prompt like, pineapple doesn't. Well, the AI immediately assigns probabilistic scores to figure out exactly what comes next. The phrase, do math, gets a super low score, like 0.23, because, well, it barely meets sense. But the phrase, belong on pizza, that gets a much higher score, say 2.37. So the AI serves up the answer with the highest score. It's literally pure math disguised as a smooth conversation. But, it doesn't just stop with the math. Enter the human in the loop. Have you ever noticed those little thumbs up or thumbs down buttons next to a chatbot's response? That user feedback creates this amazing continuous loop. It teaches the AI which responses are actually helpful and accurate. So it learns human preferences on the fly without needing to completely recalculate everything from scratch. Which brings us to part three, building the AI brain. So how do engineers actually build these things? It happens in three distinct phases. Step one is pre-training. This is where you feed the model an incredibly vast amount of unlabeled data. Think of it like giving it the entire internet to read. Step two is fine-tuning. This is where you give the AI a narrower, more specific data set so it becomes an expert in one particular task, like maybe answering questions about a company's internal docs. And finally, step three is reinforcement learning, where human scoring helps reduce biases and really aligns the model with what humans actually want. And right at the heart of this entire process is a true game changer, the transformer architecture. What makes transformers so incredibly revolutionary is that they process data in parallel. They can look at massive, massive amounts of data all at once to encode and decode meaning. We're talking about learning word relationships in billions of simultaneous iterations and doing it entirely without human direction. Now, as you might imagine, doing all of that in parallel requires a staggering amount of computational power. To adjust those billions or even trillions of parameters, which are basically the weights determining the model's decisions, you need specialized high-performance computing clusters. This massive hunger for GPUs and tensor processing units is exactly why computing power has become the single most valuable commodity in the tech world today. All right, part four, a brief history of AI. AI definitely wasn't an overnight success. Back in the 1980s, engineers literally had to manually craft rule-based AI. Then, by the 2000s, natural language processing really started emerging for probabilistic tasks. The 2010s brought us deep learning, where models figured out relationships through vectors. But then, 2019 delivered the ultimate breakthrough, GPT-2 and those transformers we just talked about. And of course, that set the stage for 2023, which completely triggered the modern LLM explosion we're living through right now. Let's move to part five, key players in the industry. So, who's actually building these giants? Looking at the major players, OpenAI has really become the consumer standard with proprietary models like GPT-4. Meanwhile, Google DeepMind focuses heavily on integrating their Gemini models straight into everyday workspace tools. Meta, on the other hand, has taken a totally different route. They're championing the open source side with the Llama series.
Then you have Anthropic, often viewed as the programmer's AI with a huge focus on deep reasoning. And we definitely can't forget Mistral AI, acting as a really strong European counterweight that's also driving open source innovation.
But hey, we really can't talk about the key players without shining a spotlight on Hugging Face. They are essentially the platform democratizing access for the broader community. By hosting literally thousands of open source models, they allow individual developers and researchers to customize and build their own AI. You don't need the endless resources of a massive tech giant to get involved anymore. Finally, Part 6, the future of AI. Zooming out and looking ahead, a few major trends are crystal clear. We're going to see highly efficient, industry-specific models built just for fields like law and healthcare. There's also a huge push for explainable AI, so we can actually understand things like biased choices or AI hallucinations. Plus, multimodality is huge. AI is expanding way beyond just text into image, audio, and video processing. Add in the rapid, massive growth of the open source movement, and you can definitely expect stricter regulations as governments try to grapple with privacy and secret data scraping. We are witnessing what's been called a complex interweave. On one side, you have this incredible open source innovation pushing the boundaries. On another, regulatory oversight trying to step in and keep things safe. And right in the middle, big tech companies racing to monopolize the space as they all push toward artificial general intelligence. It's a wild dynamic. So as large language models become permanently integrated into practically every aspect of our daily lives, how will we balance this incredible world-changing innovation with the very real need for ethical oversight? That is the ultimate question that will define our future. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you next time.